In this video, we're going to talk about the structure of metals and alloys. Let's start with metals. So metallic bonds happen when you have positive metal ions surrounded by a sea of mobile valence electrons, delocalized, meaning they're all over the place and they're kind of shared between the metal ions. Metal bonds are good conductors of electricity. They're malleable, can be flattened, and also bendable. Ductile, able to be pulled into a wire. So think about the wiring in your house. The wiring in your house is most likely copper. Copper is a metal, so we can draw it out into a wire, and it conducts electricity really well, and we can bend it. It would be kind of silly to use something in your house for wiring that couldn't be bendable, because the wire has to be run through all sorts of little nooks and crannies, and if we couldn't bend it, it wouldn't be of much use to us. Now, alloy. An alloy is a word you may have heard before. Alloys are mixtures of metals and other elements that improve the properties of the host metal. So we take a metal and we introduce some other elements into that compound, and it strengthens the metal. There are two types of alloys. The first one is a substitutional alloy. So what happens here is another atom gets substituted into the host metal's lattice. We'll take a look at a particle diagram in a second. The atoms must be similar in size. One atom substitutes for another in the lattice. Brass is a great example. So that's copper and zinc. Very similar in size, and when we introduce the other element, it strengthens the properties. So substitutional alloys look like this. So you have, like in the original, let me use a different color that's a little bit easier to see. So in the original lattice structure, it was just blue repeating here, and we substituted in this light blue in the lattice structure. So this could be just like the brass. So brass, we have copper and zinc. So we could have a repeating structure of copper, and we introduce some zinc. So these could be the coppers, and this could represent the zinc here. Okay, so when we introduce the zinc into the lattice structure, it's strengthening properties of copper. So copper by itself is not as strong as brass. But when we substitute out some of the copper for when we substitute out some of the copper for zinc, it's strengthening the properties of the lattice structure. So again, the atom that we're substituting in has to be the same size here. Okay, has to be the same size. That's the important thing to remember with substitutional alloys. Has to be the same size. All right, the other type of alloy that you can have is an interstitial alloy. So here, an additional atom goes into the intrices of the host metal's lattice. Atoms must be different sizes. Usually the alloy is stronger than the base metal. Steel is an example of an interstitial alloy. So in the diagram here, again, we have our original lattice structure, which has these large blue circles, and then we're substituting in these smaller light blue circles here. These fit into these little nooks and crannies, or intrices as they are called. So interstitial alloy, we are squeezing in things in between the particles, and this makes it a lot stronger. In this first example, it says cupronickel is an alloy used to make coins. It is made of copper and nickel. The atomic radii of both elements are shown below. Which model represents the cupronickel? Justify your answer. All right, so in A, we have copper being much larger than nickel, so nickel is able to kind of squeeze in between. And in B, it looks like they're roughly the same size. So we're just doing a substitution here. So if you look at the radii, copper is a little bit smaller than nickel, but they're roughly the same size. So B would be the best choice here, okay? Because if you look at A, the blue circles are definitely less than half, probably more like a third or maybe even a quarter the size of the copper, so that won't work. So the only one that makes sense here would be B, because they're roughly the same size. Example 2 says, a particular interstitial alloy is made of two elements, X and Y, where Y is the base metal. The alloy is made of 20% of X and 80% Y. Draw a diagram of the solid alloy that contains 10 total atoms and in a representative portion of atom types. Okay, so we need 10 total. Well, let's see. Let's draw some Y. So we know that Y is the base metal, and it's interstitial. So that means that the smaller ones, so X, is going to be smaller, and it's interstitial, so it's going to fit in between. So let's draw 8 of these. It said 10 total particles, so let's do 8 of those. Okay, and then I'm going to change my color here so it's a little easier to see. And then interstitial, we're going to fit the X's in between, so it would look something perhaps like this. Okay, and that would be my particle diagram in this case.